In this video, we are going to learn about how to create a schematic symbol and PCB footprint for L293X Quadruple H-bridge driver. The meaning of quadruple means there are 4 independent functional driver circuits inside single package. In previous tutorial, we discussed about how to design a dual operational amplifier in single IC. In this tutorial, it is going to be 4 different operational drivers in a single IC. That's why it is called Quadruple. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. This video is divided into 4 important parts. First one is understanding the datasheet and understanding how exactly Quadruple IC looks like. Second step is to creating a schematic symbol using EasyEDA, especially creating a subparts in the main part category of schematic symbol library. Third step is to creating a PCB footprint following IPC standard and using a through-hole technology. Last but not the least, the fourth step is to combining and creating a component library of a quadruple H-bridge driver IC by combining the schematic symbol as well as the PCB footprint that we have designed. So let's get started. Alright, now we are in front of a datasheet of L293 or L293D IC, which is a quadruple half H-bridge driver. What is that quadruple means? It is already said, it is a 4 different logic diagrams inside a single package. Electrical property of this particular IC is given in this datasheet in a very detailed manner so that one can use it for a driver design. It is also called half H-bridge design. Why? Because it is not internally connected and you can use it as a half H-bridge design IC. But right now, I'm not going to focus on the application, but I'm going to focus on creating a component library of this particular IC. The most important part for us is we need to understand what is the part number and what is the package. The part number is very simple, which is all about L239N NE and L293D NE. Both are a different part number with a different category of electrical property, which is important to select based on the application. But important the important part for us is both are having a PDIP package. That too PDIP 16 package with the swappable pin number. That makes us easy for us to design a component library for both of them in a single design. The interesting part or a very unique part of this datasheet is it is created at first at the time of September 1986. It's very old datasheet. Of course, this is not old datasheet. It is upgraded on January 2016. But this IC started manufacturing from somewhere around 1986. That's a great news. And now in this datasheet, we do not have a mechanical detail of a PDIP 16. Why? Because they believe it is very generic one and anybody can find that data on internet with a reference to the PDIP 8 or maybe PDIP 16 directly. That's why I have referred the Google and found this particular image which includes a required detail for a PCB footprint with respect to PDIP 16. It has almost all information that we want. So considering both of these information, we are going to start with creating a component library. Now I am in EasyEDA and I'm going to go to File and create a new symbol. As I said, it is going to be a quadruple IC design. So that's why we are going to design a 4 different subpart in a same single component library. So how do we do that? It is a driver IC. That's why we are going to use a 2 pin here. First pin is going to be sitting here and second pin is going to be sitting here. And also along with that, we'll be adding a VCC and ground in the first symbol design. So let's continue with this. Alright, now I have completed filling all the details while saving this particular schematic symbol. The moment here I'm considering is L293D because that is what easy to find on the Moser and all that thing. And I am selecting a supplier as a Moser. As we know, we can go with a DigiKey or any other supplier that you are dealing with. And also we have a supplier part number and manufacturer detail and other details that we are going to fill in this particular symbol design. So when I click on the save, it will be creating a particular part in my library. So I'll go and search for L293D. And here in workspace, you can see that the one part is created without any footprint association and all that thing. But in this, we need subparts. How many subparts we need? We need 4 subparts. In previous tutorial, we did for 2. Now we need 4 of them. So I'll click on 4 and click OK. It is going to create a 4 subpart within that. And then if I search it once again, we can see that L293D.1 and .2, .3 and .4 are created. .1 is associated with the 1A and 1Y. According to the data sheet, if you scroll it a little bit here, you can see 1A and 1Y is associated with the .1 and .2 is associated with the 2A and 2Y. Now what I'm going to do is I'm going to create an enable pin for them. So how we are associating an enable pin according to the pin diagram, you can see here 1 and 2 enable pin is connected to only one pin number. Now we are going to ensure that it is created properly. How do we do that? We'll do it now. Alright, now we can see that the entire schematic symbol for a quadruple half edge bridge IC is ready. The schematic symbol is distributed to 4 different parts, which is so-called subparts in EasyEDA. When you go to the library, you can see that L293D is visible to you. In that we have .1, .2, .3 and .4, and each one of them are having a specific information which is necessary for that particular IC. In first part, which is a .1, I have given a 1A and 1Y, which is input and output, with a VCC1 and ground for that particular thing. Ground is going to be a common one. We do not have any ground 1 and ground 2 for that, but VCC1 is necessary. Why? Because VCC1 is associated with the first enable and first input and second input, first output and second output, wherein the VCC2 is associated with the third and fourth output and inputs. That's why we are giving a VCC1 here and ground here. Enable 1 is given to a particular pin or as the first sub part. In second sub part, we do not have enable 1. And also we have given a ground in this. Why? Because we have 2 ground pins for one particular site. And to manage the entire 16 pins in the entire schematic symbol library combination, we have to give an extra ground in a second subpart. The third subpart is having a VCC2 and also a ground and enable 2. Okay, this one should be enable 2. Why? Because it is the second part of the entire design. So we'll make it as an enable 2, and in the first one, we'll make it as a enable 1. This is a good idea. So we have created an enable 1 here and we have created an enable 2 here with the third input and a third output. And last but not the least, the fourth sub part will be having a fourth input and a fourth output with a 1 ground at the output side. You can see here a couple of grounds on the other side and couple of ground on this side. So that's why we are managing the entire IC will be having the 16 pins. This is how the schematic symbol for a quadruple IC to be designed. Now it is time to create a PDIP16 footprint. For creating a PDIP16 footprint, I'm going to go to the file and create a new footprint. Here, a mathematics or a Cartesian geometry is going to be a little complicated, but absolutely same as the 4-pin or 8-pin PDIP IC. Because numbers are going to be same, and if you are referring this kind of a dimension here, it is going to make you a lot of things sensible at this point of time. If you have watched our previous video, you know how to compute the dimensions using a Cartesian geometry. One question I would like to ask you, if you consider this as an assignment, because this is going to be a very specific interview questions in case if you are applying for a very specific MNC companies which is offering you only a footprint design job role. The question is, what is BCS indicates in this datasheet information? You can see here E2A is having a 7.62 BSC. What is this BSC indicates? Just give a try with a Google and understand and remember that information, just in case required in any point of time in your career. Now we'll focus on creating a PDIP16 footprint. Alright, now I'm done with creating a PDIP16 footprint design. The calculation is pretty straightforward. It is not going to be as complicated as a first time design. Why? Because we know the fundamentals. The first important thing is these two pins are going to be 1.27 from the x-axis, which is a fundamental, and upon that we are going to add a 2.54, 2.54, 2.54 on the top side. And similarly, we are going to add a 2.54 on the negative y-axis as well. And when we are placing all these ICs and all these pins and this side pins, they are having the apart each other of 3.81 mm, which is absolutely same as a 555 timer example, or maybe the previous tutorial example, which is all about a dual op-amp. So using the same fundamental knowledge, I have designed this entire plastic dual inline or a ceramic dual inline package with a 16 pins. Now we are going to head towards the next procedure to combine with this particular footprint with the schematic symbol that we have designed. So let's go for that. For combining this particular footprint with the schematic symbol, I'll go to the library and I'll make sure that I'm in workspace, and I'll search for the IC that I have recently designed, which is all about L293D. And in that, I'll select the main part. Make sure that you select the main part. Do not select the sub part or do not select any of the sub part. Make sure that you select the main part and click on edit option, or maybe you can select it and you can see edit option here. Just click on that, and when you arrive at this particular wizard or maybe the window, just click on the footprint option here and assign the footprint that you have designed for this particular IC, which is PDIP_16. So when I search for that, you can see here I have a PDIP16 which I have recently designed. Other than that, those are the previous version which I'm not going to refer for them. I'll double click on that and it is associated. Now I'll cancel it and I'll save this particular schematic symbol, and we are ready with a component library. How to use this component library? Let's explore by going to the new project and create a new dummy schematic just for understanding. I'll go back to the library, refresh this particular library, and we can see that the component is having a 4 different subpart with the same package or a footprint that we have associated just now. So I'll select the main component and click on place. Here I will place this one, this one, this one, and this one. Let's place one more set of them so that we can understand whether they are truly upgraded or not. You can see here it is having a enable 1, input 1, output 1, and ground as well as VCC 1, which is named as U1.1, which is one part of universal IC, which is 1. Okay, and then L293D is the same number that we are dealing with. And then we have input 2 and output 2 with a ground only, does not have any VCC or enable pin. That's super, that's what we want. And then U1.3, which is including of a VCC2, ground, enable 2, output 1 or the third output and the third input. Wherein the U1.4 is having a 4th input and a 4th output with a ground pin. All 16 pins are associated in this particular schematic symbol. Similarly, you can see it for the U2 and U2.1, .2, .3 and .4. This is how you can create a quadruple H-bridge IC's schematic symbol and PCB footprint, altogether a component library in EasyEDA. I hope you enjoyed this one. Super duper! I believe that you have understood and experienced the special skill of designing a quadruple H-bridge IC, a component library in EasyEDA. It's all about understanding how to create a subpart in a single schematic symbol, which we are going to use for a design activity. If you have any questions related to this particular tutorial, feel free to ask me in the comment section below. See you again in the next video. Until then, tune yourself to make a difference.